Hello, we're going to do the lesson that accompanies 3.5. I better start my timer. Make sure I don't go over time. Okay, goals: to determine the proportion of the population that's represented by a Z-score. Proportion is the same as the area under a curve or under the normal curve. Also associated with probability. Okay, but that's probably something you want to keep in mind for later. To identify the range of Z-scores, to identify the Z-score of an outlier, it means it's outside of plus or minus 3 standard deviations. To identify the Z-score of the mean, to determine the percentile that is represented by a Z-score. Okay, note number 1, we use Z-scores to determine the proportions that are not represented by 67, 95, and 99.7%. Z-scores range from negative 2.99 to 2.9. If it's anything outside of that, right, above plus or minus 3 standard deviations, it's not going to work. Z-scores less than negative 2.99 are outliers and represented by 0% of the population. It can exist, right? But if you have read or seen any of the videos, anything that's outside of that is in physics deemed something significant. Z-scores greater than 2.99 are also outliers and represented by 100% of the population. The mean has a Z-score of 0.5 or 50% of the population. Z-scores times 100% is a percentile. You would have already realized that in the video from last week. Given the Z-score, determine the proportion that is represented by in the percentile. Okay, so a Z-score of 0.53, if you can see it, 0.5 and 0.53 is where they intersect. So 0.7019, 0.7019 is that percentile or proportion. You want to multiply it by 100%. Is the proportion, which is equal to the 70th percentile. Okay? Z-score of negative 2.1. Negative 2.1 is 0.0179. Times 100% is equal to 1.79%, which is the proportion. And that's equal to the second percentile. Means that 98% of the population is above the person represented by this Z-score. Find the Z-score that corresponds to each percentile. So if you have a 97th percentile, you have to divide that and go backwards. So 0.97, that's the inside of the table. 0.97, I don't know whether you can see this, so 0.97 is there, 0.97 is there. So 0.97 looks about like this one is close, but this one is closer, right? So we'll see if you can see that. Okay, there you go. Okay, so 0.9699 is close or closer. right? So that's the same as 0.08 and 0.17. So you add those values together, so it's 1.78. For the 5th percentile, you have to divide it by 100% and then find that 0.05. 0.05. 0.05. Can we see that? Yes. Okay, so 0.05. 0.05. Okay, there's one of them. 0.05, 0.05. So we have 0.05 or we have 0.495, right? So we have to decide which one is closer. We can do this one, 0.05, negative 1.6. We could also pick this one, 0.4 and negative 1.6. So we can add those two together. So negative 1.64 or negative 1.65 would give us the same answer. Negative 1.64 or negative 1.65 would give us the z-score. Okay, given the mean is 35, the standard deviation is 5, answer the following question. What proportion of the population? So proportion is only as a result of a z-table. And you've already found that on page 398. Okay, is represented by a value of 12. 12 is very low in comparison to the mean of 35%. Okay, so when you take that and take a look at it, it's really, really down far. So our mean is here of 35. If we go up by groups, I can already add 5s really quickly, subtract 5s. I already know that 12 is way, way over here, right? An x value of 12 is way over here, farther than what my minus 3% or 3 standard deviations. So I can go So I'm going to use the z-score. What proportion? So I need a z-score. Use my formula. I'm subbing in my mean of 35, my standard deviation, and the value of 12 is my data point. So I sub that all in. So I've got 12 minus 35 over the standard deviation, of 5. So that gives me negative 23 over 5. That gives me a z-score that's way, way outside of the plus or minus that we've talked about. Oops. So that z-score is outside of anything that we could have possibly used, right? Because we only go to a z-score of negative 2.99. So it's outside of our range. outside of plus or minus 3 standard deviations. Therefore, x equals 12 is an outlier. It's to the left, therefore represented by 0%, okay, because it's to the left. What proportion of the population is represented by a value of 40? Well, x is equal to 40. See diagram. There's 40 right there, right? So we know that that's inside the range of our 68%, but if we want to, we can get it more specific to answer the question. So we're subbing in an x value of 40, a mean still of 35, and a standard deviation of 5. So 40 minus 35 divided by 5. So we already said that the z-score is normalizing all of the values to this general normal curve. That is the z-score of 1. That's the same as 1 standard deviation, which we already said. So if we go to 1 standard deviation, or a z-score of 1, we can find that it is 0.841. I think that number says 3. 8413. Times 100%. So what proportion of the population is represented by this value? 84.13% of the population is represented by a score of 40. But you could calculate that as well, right, if you wanted to, on your diagram. What proportion of the population is the value between 12 and 40? Well, because 40 is at a score of 40 is 84.13%, and this score here was 12, and that was 0%. So 84.13 minus 0% is equal to 84.13%. So 84.13% of the population is between a score of 12 and 40. Please do the assigned homework. Email me if you're having any problems.